Assalamualaikum and good evening all. Thank you to attend this session. So as we promised in the last meeting, today we want to explain our subtopic. So last meeting we discussed the problem and what we find it. Today session is the final progress. Without delaying any more time, I give the president to continue the session.
All right. Thank you, Hafiz, for conducting this meeting. So today I want all of you to present each of your subtopic. As you know, we have divided our subtopic to our friends. So our friend don't know what your topic really about. So I hope you all can explain briefly to our friends about your subtopic. So we all can understand the purpose of this PBL. So for the first subtopic, cyber physical system, I would like to call Afiq to present.
Okay, thank you, Mohit. Now, I will explain about my finding for my cyber physical system. What I got from the research is the meaning of cyber physical system, how it works, what benefit for the smart factory and the future, and what most important is about the process and working principles. I also doing some finding about smart sensor, which that are the important, especially for smart factory. I also get to know about the technologies that been used in the manufacturing industry. A cyber physical system is a physical entity that is connect or enabled via the internet, such as a pump or compressor, and it is embedded with a computer and control component, such as sensor and actuators. Given an IP address, such an entity can monitor itself, generate information about its own function, and communicate with other related or even external entities. It is a self-regulating and autonomous operation. Core principle of Industry 4.0 is that manufacturing company will be able to achieve productivity, high efficiency, and autonomous operation of the product process by ensuring that machine or plant equipment, logistic system, work in progress component, and such other aspects as people directly communicate with each other in order to achieve collaboration. Okay. And then that's all from me for the explanation about the physical system. Okay, thank you.
All right, good. From the previous meeting, do you already solve it? The problem that you face?
Yeah, I do more research about my subtopic and I can relate it to IR 4.0.
All right, thank you, Afiq. Now I go to Hakim. Can you explain about your Internet of Things for yourself?
Okay, thank you, Mr. Chairman. Assalamualaikum. My name is Nur Lokman Hakim bin Azmi, and I will explain about Internet of Things (IoT). Okay, basically, IoT is a network in which all physical objects are connected to the internet through network device or router and exchange data. IoT allow object to be controlled remotely across an existing network. IoT is very good and intelligent technique that reduce human effort as well as easy access to physical device. This technique also has control feature by which any device can control without any human interaction. IoT is a key part of the Industry 4.0 strategy which work to create flexible and connected digital factories where communication is facilitated between all parts of the system. The best aspect of today technology like IoT, AI, and big data is their range of application. So most industries use IoT to improve their productivity and produce product efficiently.
Yeah, mostly current industry use IoT to transfer data over network without the need for human to human or human interaction with a computer. Okay, thank you, Hakim. Next, how about you, Hafiz? Please explain what you find in the cloud computing.
Right. Thank you, Mr. Muhib. As President, first of all, I would like to tell you that the part that I made has a good point in it, starting with an introduction followed by other point. Regarding what I got during the research of this topic, what I got from cloud computing is the uses of cloud computing in today's industry, even more so on in the era of Industry Revolution 4.0. In general, the technology has not yet been fully used in Malaysia, but it has spread all over the world. There are many multinational technology companies that create this cloud computing, including Google, Microsoft, Amazon, and so on. Right?
Oh, so multinational technologies company use this system for their project, right?
Yes. Mostly this industry use this to secure the system or collect data.
All right, thank you, Hafiz. That's a really a good research. Now I will continue to Amma. Please explain your subtopic.
Thank you to Mr. President Ahmad Muhib. And now we explain a little bit about connective computing. First of all, we should know what is connective computing. Connective computing is closely connected to the artificial intelligence AI, and that is model human mental process by identifying pattern using a computer model. Essentially, connective computing is based on the application of machine learning algorithm to identify and interpret complex data set over an extended period. The goal of this procedure is to provide a set relevant outcome to the user, with the first one being the most probable answer to the question posed by the learned data. In addition to more data, Smart Factory will gain the potential of faster network infrastructure, enabling near real-time analysis and decentralized decision-making through edge computing. One of the primary benefits of connecting computing is ability to effectively translate amount of data into usable, actionable tools and information. With the ability to mimic language, connected computing can develop draft of process documentation, troubleshooting guide, maintenance method, and more, which can be fine-tuned by the expert in those fields. Next, I will give you 4 examples of connected computing that we use in this era of science and technology. First is Siri, Google Assistant, Cortana, and Alexa. All these are use voice, then convert your voice signal into computer language command that can perform tasks such as searching for request song or change computer language into sound signal so that the voice assistant can give you the information you are looking for verbally in picture or video accurately and quickly based on the stored data. That's all for me. If anyone still not clear about the connected computing, anytime can ask me. Thank you.
All right, thank you, Amma. Also, your subtopic quite difficult. Good explanation, by the way. Now, how about you, SCADA part? This part consists of 2 people, right? Shahir and Idham.
Yes, Mr. President. Me and Idham take this part for this subtopic, but I take for SCADA related with PLC, and Idham take related with PID.
I see. So, how is it going?
Oh, okay. Thanks, Mr. President. Okay, my name is Shahir Aiman bin Syari. I will explain about SCADA related to PLC. Okay, first thing first, SCADA is stand for Supervisory Control and Data Acquisition. SCADA is monitoring software use this industry as software. It help control the hardware and make a record of the data collect from a remote location. SCADA software is connected to computer, graphical user interface, sensor, and network data communication in order to provide a broad picture of the process. Within this context, management teams in this industry rely on SCADA to monitoring progress and make operating correction through the plan. Okay. For the PLC, PLC stand for Programmable Logic Controller. A programmable logic controller is installed to monitor sensor. In this manner, a PLC stand for data collection, receiving critical information about the flow and input within the system. To this end, the PLC will also perform basic intervention, triggering output when the parameters programmed into the system are met. A PLC is a versatile piece of equipment which hold up under harsh condition with advanced option for programming and real-time usage. That what did I get just now?
Okay, good Shahir. Yeah, in our industry, mostly use the system to monitor and control system in automatic mode. So the system is very important and brilliant to manage and maintain efficiency. Our TMB use the system at their power plant to control their genset. Right, thank you Shahir. Now for the last one, Idham, how is your part for SCADA with PID?
Thank you, Mr. Chairman. Now I will explain a little bit about PID controller. So what I've done research it is before the programmable logic controller PLC existed. Industry used proportional integral derivative PID controllers widely in many automatic process control application into the industry to regulate flow, temperature, pressure, level, and many other industrial process variables. PID controller use a control loop feedback mechanism to control process variable and is the most accurate and stable controller. For example, in previous way for industry, the operator must monitor the temperature gauge and change the fuel gas valve accordingly to maintain a constant temperature of the water discharge from the industrial gas heater. The operator must slightly close the gas valve to return the temperature to the correct level if the water temperature rise too much. He has to open the gas valve if the water get too cold. But now the system can be automated if industry use PID controller or PLC. That's all for my explanation.
Okay, thank you, Idham, for your explanation. Thank you all with your explanation and your efforts to study more deeply about your topic. If there is nothing else, we will adjourn our session for today. If there is any problem, please let me know. Now I will pass to Hafiz for close the session.
Okay, thank you, President and all. So this is the last meeting for our BBL. I hope you all can submit your report as soon as possible for easier to compile all the report. I hope we all can together in the future. If you have any question, please let me know now.
So far.
No, sir.
So far clear.
Alright, if there are no questions, I will end this meeting now. Thank you.
All right, thank you all.
Thank you.
Thank you.